So tonight we're really going to be talking about the results chapter and quantitative and qualitative, basically how to conduct and interpret and write that. And I'm going to exemplify that for you throughout. So without further ado, I think we're all good to go. So we'll just jump right down to it. So the first thing I thought about was, okay, gosh, is there some analogy? So for some strange reason, the idea of threading a needle, which I attempted to do the other day with help of a 10-year-old because I couldn't see. So I said, well, what's the relationship between these things? Well, when you thread a needle, you're using that threaded needle just to sew on one button, okay? Well, ditto for this results chapter, right? You're just going to do it just one time in your life, and that's it. Then you're done, okay? So know that. Also, threading a needle isn't the end in itself. It's to hold a button on or to tie something together. That's the whole point of this, okay? Ditto with your results chapter, okay? It's just one part of one project in one degree in one part of your life. And a part of your life that's going to be over before you know it, all right? Then you need the right ingredients, right? You need a needle, you need a thread, and you need good eyes, which I learned. And here you need software, okay? You need some knowledge, and you need time. And finally, and more importantly, and most importantly, you need the right attitude. You don't go to sew a needle, to thread a needle, and then you can't do it, and you're like, well, you're going to give up. I'm not going to, sew the button on. Well, ditto with the results chapter. You need to have the right attitude. You can't give up. You've come this far. You've gone through, and you've done all your coursework and your comp exams, and you've passed through IRB and all their hoops. So you can't give up at this point. So I want to just encourage everyone, just stay with it, okay? All right. Now, let's get into figuring out how we're going to conduct these results. So we're going to talk about basically quantitative results and qualitative results. And I want to talk with regard to the quantitative results, basically the overall strategy, how we should clean the data, descriptive stats. I'm going to go over many of the common analyses and the reporting of those. And then with qualitative, the two main types that I see are really basically a grounded theory approach and a phenomenological approach. And I'll talk about that. I'll also talk about some of that data setup for the qualitative and talk about inter-rater reliability as well. And then we'll do some question and answers, not only at the end, but throughout. So all you have to do is go to your chat window on your right-hand side, and you can chat in a question, and then my colleague here will express them to me and show them to me. Okay, quantitative results. So the basic strategy is as follows. First of all, you have to have the correct analyses. If you do the wrong analyses, one, it's going to be inaccurate because you're using the wrong level of measurement there and you're approaching things the wrong way. So you need to have the right analyses. Well, the right analysis is based on just two things. A research question stated in statistical language, and you have to know the level of measurement of your variables. On a website, we go over level of measurement. You can Google it. Basically, you have categorical or nominal level variables. You have ordinal level variables, and you have continuous level variables. And when I say continuous, what I mean are interval and ratio level variables. So if you have, what's the relationship between two variables, and they're both continuous level, we're going to be in correlation land. If we're saying what are the differences on this continual level variable by some categorical variable that has more than three or more levels, we're going to be using ANOVA. So you need to get the right analysis. That's for starters. After you have the right analysis or analyses, then you need to clean your data. Then you should describe your variables. And I'll talk about what that means. Then you need to conduct the analyses. You need to be mindful of the assumptions of the analyses. And then you have to present your findings and then summarize your findings. Alrighty. How do you clean your data? Well, for sure, you need to get rid of outliers. What's an outlier? This is an observation that is outside of your normal bell curve, I'll say. They're on the tail ends of that bell curve. So how do you assess for these outliers? Well, say you had a score like creativity. Okay? What you do with your scores, you have to standardize your scores. That is z-score. Okay? Z-score your variable. Then, when you look at those z-scores, someone with a plus or minus 3.29 or greater, they're considered an outlier. So you want to get rid of these people. They're definitely, regressions are very sensitive to it, but for all the analyses, you don't want these outliers. Secondly, you want to look for missing data. If you have missing data, you don't want to have to throw out the entire person or participant just because they missed one item out of 10 items, okay? What you can do is impute a value there. So SPSS and other packages have the ability to put in a missing value. And in the old days, they used to just throw in the mean of all of the entire data set, okay? You looked at the mean of, say, creativity, and then they just stuck in the mean of everyone's score. So, but now this multiple imputation really takes into account the entire data set. And taking into the entire data set really most accurately and very, very quickly imputes that missing data. Next, you should create composite scores. Okay. So the composite scores are just the idea of averaging or summing all the different items that go together to create that score. So maybe creativity has numerous different survey items or self-esteem or different tests or whatever. Okay, so you want to just average or sum those. And you should be careful that a lot of these surveys, they do have items that are stated in the reverse way, okay? So if there's reverse coding, be sure to check the manual in that scoring scheme to make sure that items are properly coded and then computed. If you messed up and didn't see where the reverse coding happened, when you conduct the Cronbach alpha, okay, then you're going to see, hey, one of these items are really off, or the alpha is really low. So when you conduct the Cronbach alpha, you also want to look for and click if an item was deleted, what is going to be the reliability. And then you can identify and say, hey, gosh, that one particular item is really off. The alpha goes way up without it. So you should look to see if that one, in fact, needed to be reverse coded. Okay. So here's a question. So what tests in SPSS is used to identify outliers? Really, what you want to do is conduct descriptive statistics and go to descriptives. And what you want to do is click on the button that says standardize. Okay. If you click on the button that says standardize, what it's going to do is create a brand new variable with all the z-scores or standardized scores. And then all you have to do is sort that new variable, those z-scores, from ascending to descending, and look at the end. Look at the first scores and see if there's any 3.29s, and look all the way at the bottom of the data set to see if there's any negatives, okay? Again, outside of this range of 3.29. Let me see here. Okay, question is, what is Cronbach alpha and what's its function? Well, the idea of the Cronbach alpha is to see how well are people, it's a measure of consistency. So if you had a creativity scale and you had 10 questions in creativity and you were a very creative person, you should score high consistently on all those items. You wouldn't be high in creativity in one item and low on the other and middle on the other. So a scale that has consistency or has reliability, that is, people should answer those items in a consistent fashion. All right. Okay, so I'm just going to go on. Okay. All righty. So descriptive statistics, basically we're talking about means and standard deviations. And what I mean by means and standard deviations are just for the continuous level variables, which, as I said earlier, are really, I'm talking about the interval and the ratio level variables. The other type is frequency percentages, as the table below shows. So any of your nominal or categorical level variables and any of your ordinal level variables, basically you just want to give them a count and a percentage. All right. All righty. So now we're going to start drilling into some of the most commonly and frequently used statistical analyses that most of you are going to be involved with. Alrighty, so let's just get right to the first one. Chi-squares. So chi-squares really come in two ways. It's really considered goodness of fit and a test of independence. So I'm just going to scoot to this next slide for a second. So the goodness of fit basically looks at I'll say a 1 by X number of categories, variables. So in this case, I'm looking at political affiliation, and you can see, Republican, Democrat, Green, Independent, Libertarian, and the goodness of fit would say, and these X's would represent counts of people, okay? So the goodness of fit would say, do one of these counts really differ from these other counts, all righty? Now, what most people are used to are really the 2 by 2 by 2, 2 by 5, or whatever. So in a test of independence, really you can have any number of categories here, and you can have any number of categories here. In this particular case, I have a 2 by 5 chi-square. All right. So let's go back. So the chi-square analysis really answers, is there a relationship, for example, between these two variables, gender and affiliation? All right. There are assumptions of the analyses. One assumption of the chi-square is that each cell has to have a count of 1. That is, you shouldn't have zeros in here. All right. You should have at least a 1 in each one of these boxes. And the expected value, 80% of the cells should have an expected value of 5. An expected value of 5 is if you had 100 people, okay, in my 2 by 5 box here, if you had 100 participants, the expected value would be would be 10. Is that right? No, it would be 20 in each box. 10 in each box. You have 10 boxes. You have 10 boxes altogether. If you had 100 participants, you would expect, if there was no relationship between gender and affiliation, you would have 10 observations or 10 individuals in each box. And it's easy to calculate. So actually SPSS and the analysis I'll show you in a moment present both the frequency and the expected value. And again, 80% should have an expected value of at least 5. Now, what happens if you don't meet these assumptions? Well, then you need to be really tentative with your results, right? Okay. Now, let's go ahead and conduct the analysis. So I'm going to scoot this window over here. And what I'm going to do is select a chi-square. Now, this happens to be our own software. Okay. And I will, and I will blow it on up. And I think that probably helps. Okay, so we just go to chi-squares I've just selected. And basically, you just select your variables, and I'm selecting gender and political affiliation. I hit conduct your analysis, and then download results. Our application, obviously, is just very simple. Okay, so here you have descriptives. That is, all we have is 2 nominal level variables or categorical variables, and just really you should describe how many participants are in each one of these groups. And a nice table helps to show that, right? Okay. So after that, then you should present the means and standard deviations. This happens to be the variables in the data set that I'm using. Okay. Just show everyone what the means and the standard deviations are. ID, obviously, you don't need, right? That's just the participant ID number. So in the chi-square analysis, basically you want to, in the first paragraph, really talk about the two variables. So to examine this research question, we're assessing the relationship between affiliation and gender. And then you should talk about the levels in each one of these variables. So political affiliation in my data set has 3 levels. Gender obviously has 2 levels. You should show and share what the result of that chi-square is and the probability level. And when that chi-square is significant, it does suggest that there's a relationship between these 2 variables. Alrighty, then you need to interpret that output. Well, I'm just going to jump ahead to show you. Here is the table that shows the number in the front. So first of all, you should label these tables accurately, which is a chi-square between political affiliation and gender. We're showing the levels of political affiliation here. We're showing the gender and the levels there. And good. So, and then we have the frequency of male Republicans, happens to be 27 here. You can see 36 individuals were both female and independent affiliated, and ditto for the other 4 types of combinations. Alrighty, you should also present your chi-square, that's the degrees of freedom of the chi-square, and the probability of that chi-square. Now, inside is the expected values that we talked about earlier. So when we see that when that chi-square value is significant, now we want to interpret, okay, gosh, what is the relationship between gender and political affiliation? Well, you can just eyeball it and say, gosh, and we talked about that the expected value, well, this is slightly different. We had 10 cells before, we only have 6. But you can see that there's more actual people who were male and Republican than that would have been expected by if it was equally distributed, right? So what we see here is that there's more males who are Republican, more male Republicans than would have been expected, and there happens to be, in this particular data set, more females that are independent than were expected, all right? And then we'll report that and just state that in our description, okay? All righty. I'm going to move this back over and continue on. All righty. Okay. So, and I'm just getting the message. So, if we don't get to your question, we'll definitely respond to you via email. So, fear not. All righty. Let's go on. Pearson correlation. What does a Pearson correlation answer? Well, a Pearson correlation, to begin with, is the relationship between 2 continuous level variables, okay? And it assesses, hey, is there a relationship between them? And if there is a relationship between them, is it a positive relationship, a negative relationship, or no relationship? So that's the essence of the correlation. And lots of studies, in fact, I just got off with a gentleman 45 minutes ago, what's the relationship between A and B, okay? So there's lots of questions look for this. Now, there are assumptions associated with this analysis. Specifically, it has to be linear in nature. That is, your 2 variables need to have a straight line relationship, not a curvilinear line, as you see here. Okay? It has to have homoscedasticity needs to be met, which means that basically the residuals over the predicted values are randomly scattered. This is not a particularly good example of that, by the way, but that's the example I got to come up with. When there is no homoscedasticity, okay, or heteroscedasticity, then basically there's a pattern which is often in a cone shape, as you can see here with my pointer. All right. So that's the second assumption. And then third, the variables need to be normally distributed. What that means is there needs to be a lot of people bunched up. Here's the frequency. There needs to be a lot of people bunched up in the middle, okay? And fewer people at the tails here. Okay. If it's not normally distributed, what you'll see is people stacked on one side or the other. Right? They may be stacked over here, as you can see, and there's hardly any people over in this tail. Okay. So these are just three of the assumptions associated with even just a basic correlation. Well, okay, now let's go ahead and conduct a correlation and see what we find. So I'm going to add another, I'm going to start over. I really did start over. Okay. And upload, excuse me. Okay. So to conduct a Pearson correlation, we can just select the number of variables. You'll have to pardon me. My browser does not have access. Alrighty. So, okay, so we're going to select the matrices. Then we're going to just select three variables, okay? So let's just go ahead and correlate science post-test, science pre-test, science post-test, and science follow-up. We're going to go ahead and conduct the analysis. Let's just go ahead and download the results. And you can just see how easy this is. Here's our old friends, the descriptives. And for a correlation, basically, again, the first paragraph, you want to talk about that you're relating certain research variables. That you're relating three variables. Okay. Then, you want to talk about what a positive correlation is. And then you want to show with the matrix. Let me see if I can do this. Okay. And then you want to show what the variables 1, 2, and 3, and 1 and 2, that covers all the permutations. Obviously, variable 1 with variable 1, it's going to be perfectly correlated, but we're really interested in variable 1 correlated with variables 2 and 3. And you can see there's a positive correlation, and you should interpret that correlation. For example, in a significant positive correlation, when one of the variables increases, the other increases. So what that positive correlation indicates is that when people have higher science pretest scores, they also have associated higher science post-test scores. You should also present the scatter plot of the variables. Okay, you can see science pretest with science post-test is sitting here and so forth. And you can see that they're positively correlated. And the figure title goes down below. Alrighty. So I'm going to scoot this back. Okay, so I do have a question before we go on. How do I know when the data I have is normal, etc.? Well, what you have to do is conduct a normality test. Okay, so SPSS does have a test for normality. And I don't have SPSS right here with me, but basically you just need to conduct a test just to assess that normality. And you'll see, you can just request that, okay? And you'll see both the distribution of the scores as well as that nice little, excuse me, you'll also see, you can just request this figure and you can request that line and you can see, and then you just eyeball it, okay? Okay, I mean, you could run a Shapiro-Wilks too, but this is kind of just a visual examination of it. So, good question. Okay, and okay. Okay. Where did the expected values come from in the chi-square? Well, I'm going back a little bit. Well, we'll catch some of these questions as we go through here. Okay, so I'm just going to carry on here. Okay, and again, I'll answer those questions offline as I'm kind of moving through it, and we're halfway through the hour. Okay, so the independent sample t-test. This is an incredibly common test, okay? So what the test answers is the following. So here's a question for all of you out there. Let's imagine we have two groups. We have males, we have females, all right? Now, let's assume that we have 6 participants, participant 1, 2, 3, 4, 5, 6, and they have scores 1, 2, 3, 2, 3, 4. The mean difference between the males, which have a mean of 2, and the females, which have a mean of 3, is a difference of 1. Here's my question. Would you suspect that these two groups differ, males and females, with a score of 1? A difference of 1, rather. You ready? The answer is no, because even within the group, they differ by 1. So if they differ within males by 1, and they differ between males and females by 1, we can't say that there's group differences, because males also differ by 1. So let's take another example. Here, we have males and females. Again, you have a mean of 2 and 3, same difference of 1, but look, the males only differ by 0.1 among themselves. And ditto for the females. They only differ by 0.1. Now are we willing to say that males and females differ on these particular scores? You should say yes, because while they differ by 1 between them, their within difference is very small. And in fact, the t-test and the ANOVA we're going to get to, and these other F values, are really looking at the differences between the groups divided by the differences within the groups. Over here, the differences between the group is, say, 1. The differences within the group is, say, 1. 1 divided by 1 is 1. That doesn't sound too big. Here, differences between the groups are 1, but the differences within the groups is 0.1. And 1 divided by 0.1 is 10. So the large, and that's the F value, essentially, roughly. So the larger that F value, the more likely there are that we can say that there's reliable differences between groups. All right, and we'll conduct this test in just a second. But before we get there, we should talk about some of the assumptions. There's assumptions of homogeneity of variance. Basically, what that means is that the standard deviations, even though the mean of the males are 2 here, there's a standard deviation and a variance there. Ditto for the females. And basically what we want to say is that females' variability is equal or homogeneous or similar to males' variance, okay, or standard deviations. So that's the homogeneity of variance, and that's typically assessed with a Levene's test. And I'll share that with you in a second. Okay, then there's also normality, and we talked about that. Alrighty, now let's go ahead and conduct those analyses. So, scoot this back over. All right, let's go ahead and add another analysis. We're going to continue. Yep. Okay. So we're doing an independent sample t-test, and we're going to hit continue. And basically, we're going to look at, let's just say, creativity by gender. Okay. By the way, you'll notice in the independent sample t-test, you must have a categorical level variable. And that categorical level variable should only have 2 levels, as we have here in gender. We're going to go ahead and conduct the analysis, and we download the results. And open it up, and what do we find? We're going to go down to independent sample t-test. We're looking at creativity by gender. We looked at normality using the Shapiro-Wilks, and if it's significant, just state that. But there's also good references to state that, hey, gosh, it may not really affect the robustness of that test. Then we're also looking at the Levene test, which assesses the assumption of equality of variance. We can see that was not significant. We want them to be non-significant, by the way. We don't want normality to be significant. We don't want the homogeneity of variance to be significant. Now we get to the heart of it. We need to report the results of the t-test. In this case, they were not significant. This is actually the t-value here. And then here's the probability. You want that probability to be 0.05 or less, right? Okay. And then, fortunately, though, your degree is not dependent upon finding significance. All you need to do is conduct the appropriate test, report the findings, assess the assumptions, report the findings, and let the chips fall where they are. Okay, so, and then this is how you would report an independent sample t-test for creativity by gender. which is basically stating the variable. This is the t statistic. Those are the degrees of freedom, by the way. The probability of getting that t by chance. The Cohen D is reported in APA 6th edition, which is essentially a measure of effect size. And then we have our males and females with the means and standard deviations listed here. Okay, let's go on. I'm going to scoot this over. Okay. Now, the one-way ANOVA, well, you'll notice over here, the independent sample t-test, as I said just a moment ago, has two groups. Okay? Now, it could be males, females. It could be any two groups you want. Right? ANOVA is the same exact thing, except you get to add a third group or a fourth group. So the ANOVA really looks at, well, it could handle two groups, but it could handle two or more groups. That's the whole key. You have the same assumptions. Oops. You have the same assumptions, homogeneity, variance, normality, and then I'll show you how we conduct that analysis. So with this, I'm just going to start over. I'm going to hit continue, and I'm going to conduct ANOVA, and continue, and then my IV, political affiliation, okay, and let's just look at creativity, conduct the analysis, download results. Okay, open. All right, then we have our one-way ANOVA. We talk about what we're doing to examine this research questions, and ANOVA was conducted to assess if there's differences. Oops, I hit the wrong variable there. Okay, well, let me do this. Let me just redo that. Okay, so let's just start over. I'm going to hit continue. I'm going to conduct the ANOVA and hit continue. All right, independent variable for the political affiliation, and I'm just going to select creativity and then conduct my analysis. Okay, let's see how that goes. And we're going to open it. Okay, so here we're looking at creativity by political affiliation. We look at the assumptions, the Wilks and the Levine test. We're going to report the ANOVA. That's here. Here you have the degrees of freedom inside. You actually have the F value here, and you have the probability sitting here. And then we want to interpret it, suggesting there was no difference. Why do we suggest that? Well, we suggest that because there's no significant, the probability of getting that by chance is greater than 0.05. In any event, you still want to report the ANOVA table, okay? And it should look like this. Sums of squares, degrees of freedom, mean square, the F, the probability level, and the effect size. And you want to report the means and standard deviations for this means on creativity for each of the levels of the groups. Okay, there's the mean, standard deviation, and the sample size. It's also nice to create a little graph that shows you visually the differences. Now, this may look like there's differences between here and here, but heads up, the scale is at 58.5, right? So if this was at a 0 scale, they would really not look that different. Okay. Alrighty. Let's carry on. Okay, so someone asked, what is an F value? Well, as I said earlier, the F value is really an assessment of the differences between the groups, okay, divided by the differences within a group. That's essentially what an F is in real basic terms. Now, there's actually a formula for that, okay? Well, all right, so, but essentially that's what it's measuring, okay? Just to get a feel for it. Basically, just like in the t-test, when we talked about differences between a group divided by differences within a group, right? It's a similar thing for the one-way ANOVA. That's essentially what it's testing. Okay, so good question. And in fact, if we should put some formulas out there to show you, to give you a real better feel for what is actually happening here. Okay, I want to go on. So now we're going to talk about dependent sample t-test. Well, what is this answer? Well, dependent sample t-test also looks at the same scores at two different time frames. For example, a science pre-test score, perhaps as an intervention, or the semester where it goes on, and then a post-test score. Okay, that's one way to do a dependent sample t-test, is that's often used in this pre-post test kind of situation. But I just spoke with a woman earlier today, and she was looking at pastors and their parishioners. So their pastors, instead of being participant one, it would be the pastors at church one and the parishioners at church one. And we would see if there's differences between their pastor scores and the parishioner scores. Okay. You have the assumptions of the analyses of normality, and to conduct it, it's pretty easy as well. And what to do, let's just take, for example, I'm going to start over. I'm going to hit continue. I'm going to do a dependent sample t-test and click continue. And let's just look at, for example, science pre-test and science post-test. And download the results. Okay. So basically, here's our dependent sample t-test. We're looking at pre-test versus post-test. We're looking at normality. Even if it's violated, we want to say this test is robust. We want to, just as in the independent sample t-test, we want to report that t-test and the significance level. Here, that probability, 0.05 or less, does suggest that there is a difference between the pre-test and the post-test. And in fact, we're even interpreting it for you here, that the pre-test had significantly lower scores than the post-test. Well, let's see what that looks like. Here it is. The pre-test does in fact have a significantly lower mean score than the post-test. And you can see the graph that kind of indicates that as well. Okay. Alrighty. And let's see if there's any questions. Okay. I don't know what the about whether. Okay. So obviously, if you we're getting some questions about where to purchase this. So certainly you can go to the website Statistics Solutions Pro and okay, you can see it over here. Okay. Okay. So okay. So all right. So that's where you can go purchase it, and you can see. I mean, yeah, it is a heck of a lot easier than creating it in SPSS, moving it over, figuring out the tables, interpreting it. So yeah, heads up there. Okay. The repeated measures, ANOVA. Again, there's assumptions. This one is of sphericity. It basically is a homogeneity of variance assumption. Then to conduct it, and then we'll show you, again, the repeated measures ANOVA. It answers the question, is a set of scores different at 3 time points? Okay. In this case, I'm looking at pre-test, post-test, and follow-up. Okay. And you want to know, people want to know, hey, gosh, is there a difference from pre to post-test? And perhaps from post-test to follow-up, did the effect or the intervention have long-standing value? All righty. So to conduct that, you simply just go to, let's just start over. Okay. Let's just go to continue. Let's just go to repeated measures ANOVA. Okay. Heads up, on the repeated measures ANOVA, you need an ID variable, which essentially just means that you need a column that says participant 1 is participant 1, 2, 3, 4. So for each one of the participants, they just need a number associated with it. Okay. So let's just look at 3 variables, and we'll look at pre-test, post-test, and follow-up. Okay. conduct the analyses, download the results, open the results. Yeah, this is probably 1,000 times quicker than anything else that's out there. So we go through the descriptives as usual. Here's our repeated measures ANOVA. We're looking at differences between pre, post, and follow-up. We assess the assumptions. We talk about those assumptions. We then report the repeated measures ANOVA, degrees of freedom, as we've seen before. We report what that F value is, 147.66, and the probability level, which shows that it's significant. By the way, when you have an ANOVA or you have a repeated measures ANOVA and it's significant, you need to do a follow-up test. Just to kind of go back for a second. When you have, well, let me just put it, I'll stay with right where I'm at. If you have means for the pre-test, means for the post-test, and means for the follow-up, the F value, okay, just shows you that one of these groups are differing from that grand average there. What you really want to know is each group, let me just say that differently, does each time frame differ from one another? That is, does the pre-test differ from the post? Does the pre-test differ from the follow-up? And does the post differ from the follow-up? So what that means is you need to do a test here, you need to do a test here, and you need to do a test here, okay? Looks like a little smiley face. I didn't intend for that, but okay. So basically, you need to do 3 t-tests there, okay? The Tukey post hoc is one such test, all right? Okay. So, and before we get there, okay, now I need to, all right, hang on one second here. I need to go to here, and I need to cancel all of that. And then I need to go to here. Okay, great. Okay, so we're going to go right from current slide. Okay, so let's go to the next test. The next test is linear regression. So what does a linear regression do? First of all, linear regression, in this particular example, has one predictive variable and one dependent variable. That dependent variable, by the way, is a continuous level variable. The independent variable, in this case, is a continuous level. But you can also have a dichotomous nominal level variable, or you can have an ordinal level variable or a categorical variable with 3 or more levels, but you have to dummy code those variables. So heads up, those need to be dummy coded. In fact, our application does that automatically. But in this particular case, I'm using a continuous independent variable, IQ, and I want to see if it predicts creativity. And essentially it's asking the question, out of all the reasons why creativity can vary, what percent of those reasons are accounted for by the independent variable or by IQ? That is, what percent of that overlap is happening there? Now, there are assumptions associated with that already. So the assumptions are normality, we've talked about that, homoscedasticity, we've talked about that, and multicollinearity. Multicollinearity is essentially when you have more than one independent variable, to what extent are these, let's just say 2 independent variables, to what extent are they correlated with each other? If they're really highly correlated with each other, it's not going to accurately reflect how much of the variability in the dependent variable is accounted for. So when you have more than one independent variable, you have to assess the multicollinearity. That multicollinearity is often reflected in a variance inflation factor, or VIF. And you can just request that in SPSS. We actually present it here in the analyses. And you don't want a VIF of, some people use a number of 5, some people use a number of 10, but essentially you don't want high correlations between or among your independent variables. Okay, let's go ahead and conduct that analysis and see what happens. So let's just go ahead and start over. Let's go ahead and hit continue. And let's go ahead and conduct a regression. And let's go ahead and click continue. And just for the heck of it, let's just look at creativity. And let's go ahead and select two predictors, okay? Let's go ahead and select IQ, and let's go ahead and select science, right? Does your science and IQ predict creativity? And let's go ahead and conduct that analysis now. So, easy enough, download the results and open up the results. Okay, and let's open this up so everyone can see it. Here are all trended descriptives, and we get right to the multiple linear regression. Basically, again, you want to say in that first paragraph, hey, I'm conducting a linear regression to see if IQ and science predict creativity. Prior to the analyses, you want to look at the assumptions of normality. You want to show that plot. And then if the assumptions are not met, okay, and you want to talk about that. Homoscedasticity, you want to look at and plot that. And you can see, I'll just scoot down here, and you want to present those plots, okay, of those assumptions, okay? Alrighty. Then you want to actually really essentially do three things in the write-up. One, you want to present the ANOVA, okay, the F value. Basically, this says, hey, is it a good model? With these two things, IQ and science predicting creativity, do they do a good job, okay? And we look at that significance level for that, okay? We also want to look at the R square. Well, that gets at what I spoke about earlier, which is to say, hey, gosh, out of all the reasons why creativity can vary in this particular data set, IQ and science, they account for 19% of all that variability. Not so bad. Having said that, there is 81% variability unaccounted for, so that might be future research, right? So it's a little discussion section point there. Alrighty. Then you want to now interpret the significant predictors. So I'm just going to jump to the table here. This is a APA 6th edition table for linear regression, and you have your two predictors here, the betas, the t-value, and the probability. What this says, when that probability is 0.05 or less, what that's indicating is IQ does a good job of predicting and accounting for variability in that creativity score. Once we know that it's significant, that IQ is a significant predictor, you want to interpret that predictor. Okay, well, in fact, that's what we do. IQ is a significant predictor of creativity. So we report that beta coefficient, 0.26, okay? Alrighty. And what this suggests is that for every 1 unit increase in IQ, creativity will increase by 0.26 units. Science pretest was not a significant predictor of creativity, and you do not interpret that beta if it's not significant. And then we present the table as I presented here. And then we just talked about the plots already. I hope this is all making sense to you. Alrighty. So, okay. So some of the questions come in. I'll get to these other questions because I think I'm lagging on the questions here. Alrighty. So we talked about regression. Now, there's other types of regressions too. Multiple regression. Well, let me just jump to the chase. It's all about the DVs except for the multiple regression. Multiple regression just basically says you have more than one predictor, okay? If you have one predictor and it's a continuous outcome or continuous dependent variable, it's a linear regression. And if you have more than one predictor variable, it's called multiple regression. No big deal. Okay, now there's other types of regressions. Logistic, ordinal, and multinomial. Logistic just means that the outcome variable is dichotomous. Male, female, yes, no, die, alive, work, don't work, or whatever, pass, fail. So dichotomous outcome here. Ordinal simply means that you have an ordinal level outcome variable. So this could be, ordinal is ranked ordered data. So it could be age groups, you know, birth to 5 years of age, 6 to 30, 31 to 100, okay? So it's just ordinal or ranked ordered age groups in my example. Multinomial is simply that there's a categorical variable, like logistic, but logistic only has 2 levels. Multinomial has 3 or more levels. So we really could be saying, hey, to what extent do these particular predictive variables really impact Republican, Democrat, Green, Independent affiliation? So it can predict categories. All right. All righty. Now, this is fantastic. Mediation and moderation analysis. And I'm going to jump to these things. I want to highlight these 2 things for a couple of reasons. One is that a lot of times, where's my little pen? Okay. A lot of times people have variable A predicting variable B. Okay? And in another research question or hypothesis, they'll have, okay, gosh, does variable B predict variable C? All right? But what they never do, okay, and which is logical from this, I don't know if it's a syllogism or not, but what this really implies is that A predicts B and that B predicts C. And what that really means is that B mediates the relationship between A and C. Said another way, there's a relationship between A and C, and that relationship is carried by B. All right? So that's the point here. And mediation analysis tests that. And one example of this, let me just get rid of this. And let me get out of this. Okay. So one example of this is, for example, that you find a relationship that that IQ, the independent variable, predicts creativity, the outcome variable. But so what people might say is that IQ predicts you attaining education, and maybe education really impacts creativity, which is implying that education mediates that relationship. So, to assess, in fact, if education mediates that relationship, and again, mediators carry the relationship or, accounts for that relationship or carries that relationship. Okay? To assess mediation, well, I want to go back for a second. So in that example that I just erased over here, okay, basically you can add a fancier type of analysis without having to collect any more data and really tie your research questions together. So that's the importance of just at least understanding and having a glimpse of mediation, and I'll get to moderation in a second. So how do we test this? Well, to test mediation really requires 3 regression equations. First of all, the IV must significantly predict the mediator or potential mediator. Secondly, the IV must significantly predict the DV. And third, when you put in the mediator and IV predicting the DV, the IV must no longer be significant. Okay? And how it works is like this. So if we just went to start over, and we're going to go to continue, and we're going to go to mediation, and hit continue. And here you can just simply show, the mediator. And in this case, I did have education was the mediator. Seeing how good my short-term memory works here. The IV was IQ. The outcome variable was creativity. And in about 3 seconds, you can see here's the mediation analysis, which really does several things. One, in this write-up, it talks about, this is a tip for everybody doing mediation, okay? Here are the requirements. For mediation to be supported, these things must be met, okay? As I just stated, IV predicts the DV, IV predicts the mediator, and the mediator, basically the mediator is related to the DV, and the IV is no longer significant. Okay? So, and then we actually interpret it here, okay? Okay. Then we talk, I'll just jump down to the equations. So here, you actually show the 3 equations I talked about. This is good. IV predicting creativity, that was significant. That was met. It failed here, okay? IQ did not predict education. That is, the IB didn't predict the potential mediator education. Thus, it is not, mediation is not supported here. Okay. And it had it been, we would have interpreted it. Okay. So basically, and here's the interpretation of it. We walk through the regressions and say whether or not, you know, that mediation is supported or not. And here we just actually, you know, make that conclusion. Okay. Alrighty. And Barron and Kenyon 86. That's the good. Excuse me. That's the that's the article you want to look up. All right. Okay. I know I'm running out of time, but just hang in there with me. I'm going to get to moderation. I'm going to get to your questions, and I'm going to get to qualitative. All right. So just hang in there. So moderation. Basically, it says this. Okay. It says you have an IV, IQ in this case, and a potential moderator, let's just say age. But you think, so what the moderation says is, hey, we think there's a relationship between IQ and creativity, but that relationship is either strengthened or weakened by this moderator. So you might think, hey, there's a relationship between IQ and creativity, but as people get older, that relationship between IQ and creativity get even stronger, all right? So, and to do that requires one regression, but it does require that you, it does require that you create an interaction term. Well, what's an interaction term? An interaction term is just simply the multiplication between the IV and a potential moderator. That's it. And what you do, if you were doing it kind of the old-fashioned way, which is you're going to run one regression, and they call them steps or blocks. And basically what a step or a block is that you enter them in first to the equation. Okay? Then you enter in this interaction term in a second block or step. If this term, if this interaction term is significant, then we say moderation is supported. If it's not, then moderation is not supported. Now, a quick heads up. Remember we talked about multicollinearity earlier, which was two independent variables being highly correlated? Well, gosh, if this interaction term is created by multiplying these, do you think age is going to be correlated with age by IQ? It most likely is. So to avoid multicollinearity, what you want to do is center the IV and the moderators, which is essentially subtracting the mean from each one of these. So that is IQ as a group, there's going to be an average IQ score in your sample. What you want to do is subtract the mean from each one of those individuals. That's called centering IQ. You want to do the same thing with age. Age as a group, that is your entire sample, has a mean, and you want to subtract that mean from every individual. That's called centering age. Then you want to multiply them together. That's going to create our centered interaction term. Okay? All right. So, how do we conduct that? By the way, when you have different regressions, okay, or different hypotheses or predictions or research questions like IQ predicting creativity, so a lot of people I bump into, they need an extra research question. Well, gosh, look at some of your demographic variables and look for moderation. That's going to add a few more analyses, a few more research questions and analyses without having to collect any more data. All right? So let's go ahead and do that. Excuse me. Okay, so hang on. Okay, so we're back. I lost sound for a second. Okay, so let's go ahead and look at moderation. So, and what we're going to do for moderation, we're going to start over. We're going to continue. We're going to click moderation. MOD. Moderation. Continue. The moderator variable in our case was age. Our independent variable we said was IQ. Dependent variable was creativity. conduct analyses. By the way, this particular application also centers the variables. We'll just download it. I'll show you. You can see it happens very quickly. Okay, let's just go down to moderation. Basically, we're saying moderation was assessing that age moderated the relationship between IQ and creativity. We then we did center the moderator. Okay. We then report the regression, just like we did up above. Okay. But we don't really care if that's significant or not. What we really care about is whether that interaction term is significant. In this case, the interaction term was not significant. What does that mean? What that means is that moderation was not supported here. And you can see here in our APA table the IV, the potential moderator, and the interaction, the centered interaction term. Okay? Simple. Alrighty. Now, I know a lot of people have been waiting for the qualitative, so I'm going to get to that. Qualitative, and then I'll take questions. I haven't got any more questions here at all. Okay, great. So the qualitative, first of all, top view of this thing. Sample size, there's no definitive requirement for sample size when it comes to qualitative. There's just, Creswell talks about grounded theory. You should have about 20 to 30 people. What's grounded theory? Grounded theory is looking at open axial and selective coding, and I'll talk about that in a moment. The other type of qualitative analysis that we see very frequently are phenomenological studies. That is assessing the lived experience of your participants in whatever domain you're requesting to find out about their lived experience. There you need about 5 to 25 participants. I want to tell you though, my advice is all of these surveys, all of these interviews, they need to be transcribed, read through, synthesized, thematized, written up, tabled up, and then defended. So, as few people as your committee will let you get away with, this is what I'm suggesting. If you're a multi-million-dollar funded researcher, have at it, and nothing but time and energy, go get 100 people. But my advice is, get as few people as your committee says, okay, we got it, So, and then here you can see phenomenological, you're really capturing, just a few people can do it. Yes, they say get as many people so you can, capture saturation. Where you're getting more people, you're not getting any more understanding. You're in a dissertation where you're paying tuition, vast majority of you. Let's get moving. All right. So that's the idea with the sample sizes. This is the grounded theory, the open axial selective, phenomenological lived. Oftentimes, we want to look at the inter-rater reliability of those themes that we find, and that inter-rater reliability is assessed with a kappa coefficient. Data prep, you got to transcribe the interviews. You should line number them. If you're thematizing without software, especially if it's a small, if you got 10 pages, we're just going to read those suckers. Organize the interviews by the interview question rather than by the interviewee. So I want to get the theme of everybody's responses to interview question 1. And I want to see what themes emerge there. Now, if you're using NVivo, which is an awesome software package and helps really keep you organized, there's different types of sources and nodes. Where the sources, you really need to have different documents for each interviewee. And the nodes, you should be separated by each interview question, or themes and sub-themes. Okay? Now, here's an example of grounded theory example. We're looking at the effectiveness of blocking schedule, okay? So, research question one might ask is, hey, during the first year of blocking, how did the students perceive the effectiveness of that schedule? The interview question could be, during the first year of blocking, how did you feel about your class load? Open coding looks at basic general themes. In this case, we found level of difficulty was a theme that was identified, and the amount of information taught in the classes was identified. And it would be laid out like this, okay? So you would have a table without the colors with the participant numbers. Notice not every single participant has a thought about this theme. That's okay. You have the theme, which is level of difficulty, and you may well have lots of themes, okay? And then you want to have the excerpts of what the participant said with regard to this theme. Axial coding really starts to kind of talk about the different areas of that feelings about the class load in this case. So in this particular example, that is this particular example, okay, table 1, you can see, hey, 4 of the 10 of them said, hey, there was more information that was taught. You know, 3 of the 10 said they started out difficult but got easier, and 3 of them said, hey, the class load was pretty easy, okay? So basically, you want to order these things from strongest to weakest in terms of the amount of participants that had feelings about this class load. Okay? Next is selective coding, which is a really, grabbing at one participant statement that really reflects all the axial coding, okay? In this particular example, okay, here's participant 3 that said, hey, the beginning of class was overwhelming, there were problems, but eventually I was able to manage. Having a block schedule allowed me to have study periods, so even though the test covered more information, now I can be prepared because I have more time to study. So the selective coding is really trying to capture that axial coding, all right? All righty. Phenomenological, basically we're just reading the entire transcript and getting a feel for it, and then I'm really reading across each interview question for all the participants. I'm pulling out themes and then really themes out of the passages, and then really quoting or excerpting what they had said. Okay. Quickly, when you have different themes, you should really look at the inter-rater reliability. That is, you or us or together, we've identified themes. Now, how reliable are those themes? That is, can 2 novice raters also agree that a theme is present or absent in a particular excerpt? This is the scheme for doing this. You would have 2 additional raters for theme 1. You would read the passages or the excerpts from everyone, and rater 1 and rater 2 would say, hey, that theme 1 is present or absent, okay? And rater 2 would say, hey, in that excerpt, pardon me, that theme is present or absent. You would create this matrix. You would come up with an observed agreement. That is, you want people to say, you want both rater 1 and rater 2 to say it's present when it's present. You want them both rater 1 and rater 2 to say it's absent when it's absent. Okay? That's agreement. Expected agreement is calculated as so forth. The kappa is literally calculated from the observed minus expected, divided by the sum, okay, of all of the endorsements, minus the expected agreement. Okay. Okay. Now, I know I'm moving through this kind of quickly. Here are some qualitative references that you should use. Moustakis, in particular for phenomenological. Glasser and Strauss is one of these earlier ones for grounded theory. Creswell is awesome for both. Okay. All right. It's all yours. Now, I'm open to other questions. Okay. So for sure, the webinar will be available on our site tomorrow to view. You can, show you, so you can go to our, let me go here. So you can go and purchase, to get the software. Just go to our homepage, statisticsolutions.com. Go here and buy it now, okay? All right. So there you go. All right. So what else? Okay. And of course, you can get personalized one-to-one quantitative and qualitative consulting. Here's our email address. I think that's accurate. The phone number. All right. We're interested in your feedback. Feel free to connect with us through Facebook, LinkedIn, Twitter, and Google+. Okay. I want to know what you want in upcoming webinars. The next webinar is Wednesday, January the 22nd. We're taking off for the winter break. It's going to be at 8:30. We're not quite sure exactly what we're going to be. The topic will be will be announced. And again, I want to thank everybody for your participation and attention. I'm always gratified that people who start this finish at the end with us. And anyway, I hope this was helpful. We'd be glad to assist you. And I want to wish you a great winter break, a very, very happy New Year. I hope to hear from you before then. And I'll say a wonderful good night. Thank you all so much. I really appreciate it. And stay with it. All right. Bye-bye now.